Welcome, Physics 1404, the solar system, fall 2020. I'm Ray Binge. If you'd already watched my intro and welcome video lecture, then you know kind of where the course is going from here. But let's go ahead and talk a little bit more about why we even study astronomy. So what we want to do is start off with kind of a basic idea of astronomy and background stuff, and then we'll kind of move into chapters 1 and 2. So why study astronomy? Historically, it's one of the first sciences that one has ever studied. The ancient people would look up and they'd see stars at night, they'd see the sun, they'd see the moon, they'd try to figure out why things were different at different times in the sky. And the other thing is, I just think it's cool. You look up in the sky and you see all this stuff, and it's like, wow, that's really cool. You see a nebula, see galaxies, see other planets. So this is really, really cool. Culturally, historically, different cultures, how they saw themselves had a lot to do with how they saw their place in the universe. And so culture and society is also wrapped up with science, astronomy being one of those. The other thing is that there's always something new going on in astronomy. The course, I've been teaching astronomy for a very long time, and this course is nothing at all like when I first started. When I first started, we knew a few things about a few planets in the solar system, and that's about it. Now we know a lot more. We, a few years ago, had a spacecraft that actually landed on a comet here. We've visited asteroids and comets up close, and we've actually seen Pluto just a few years ago for the first time. And so these were all things that were just like mysteries because these were tiny little objects really far away, and there was like almost no hope of seeing what they were really like up close. Okay. About 3 years ago, I had the opportunity to take this photograph right here of a solar eclipse. I was actually able to travel to exactly where the solar eclipse was going to be, and so I got that photograph right there. So again, why do we study astronomy? Same reasons here. It's cool. But wait, self-preservation was in there. How does self-preservation arrive in this? Well, the Earth is actually a planet in the solar system. And so understanding Earth's role in the solar system becomes key to understanding the position here. We look at the moon. It's got craters on it. Where do the craters come from? Well, not that long ago, a half century ago, they were arguing about where the craters came from on the moon. 75 years ago, they definitely didn't know where the craters were. They had arguments here that maybe the craters came from dried up lake beds. Maybe the craters were volcanic craters or something. A fellow named Gene Shoemaker led the idea that maybe the craters are from impacts on the moon. Things running into the moon, asteroids slamming into the surface of the moon, giant explosion, making a crater. That turns out to be the correct answer. So that's where the craters come from. So now the question is, well, if you look at Earth, what about craters on Earth? Does Earth have craters? When we look at the moon, we see craters all over the place. On Earth, do we see craters? You know, a lot of people say, well, no, there's no craters on Earth. You know, why not? We have an atmosphere. And yet, that's a picture of a crater on Earth. Sort of between Flagstaff and Winslow, Arizona, is this big hole in the ground that's, you know, about 3/4 of a mile across, several hundred feet deep. That's from an asteroid that slammed into Earth in the distant past. There are lots of craters on Earth. When we're talking about impacts on Earth, Texas has several craters. The reason you don't see a lot of craters on Earth is not that the atmosphere protects us. because if you get a big enough impact, like in this diagram on the left over here, the atmosphere is only like 50 miles across. There are asteroids out there that are 100 miles across. So that means as the asteroid slams into Earth, it'll punch through the atmosphere, it'll hit the ocean, it'll go through the ocean, it'll hit the ocean floor, it'll crack through the crust of the Earth into the mantle before the top of it has even entered the atmosphere. Okay, that's a major impact. Something like that would be devastating to Earth. Now, good news, there's nothing that big that we see coming at us right now. Bad news, we'll talk about this later, asteroids can change orbit. And there'll be a lot of things out that we don't see. So there are things that are out there that we might want to be aware of. Okay. So the question is, can it happen again? Can another impact happen on Earth? And the answer is yeah, it actually can happen. Asteroids can come by, and in fact, in 2012, an asteroid was discovered, and it passed by Earth just very shortly after it was discovered. So it was discovered February 22nd. It had actually already passed, so it already passed Earth February 15th, so we saw it on the way past us. It missed Earth at a distance of about 22,000 kilometers. That's actually lower than a lot of our geosynchronous satellites out there. So that was a near miss. 2013, astronomers had discovered something coming towards Earth, and it was approaching Earth, and we were watching it, and the day that it was going to pass by, in February of 2013, another one came by from the direction of the sun that we didn't even see. And it started flying across the sky. There's this dash cam video in Russia, and it slammed into Russia. Now, it actually didn't make it all over the ground. It blew up in the atmosphere before it hit the ground. Blew up with a force of about 500 kilotons. That's 1/2 megaton. That's like a medium-sized hydrogen bomb. And it was because this thing was about 10,000 tons across and slammed into the atmosphere, moving 18 kilometers per second. The explosion was huge. It injured 1,500 people. Good news, it was not directly over a city. Bad news is it was between three towns, and 1,500 people were injured. 6 cities actually totally damaged, and over 4,000 buildings damaged. So that was a big deal right there. We didn't hear a whole lot about this in the United States because U.S. media doesn't cover a lot of things happening overseas. But that was a major impact right there. When's the most recent atomic bomb-sized impact? Well, believe it or not, just a year ago in the Caribbean. Something hit and exploded with the force of an atomic bomb south of Puerto Rico. And so these things are still out there, and they're still coming around. Now, the next question for you, when was the last near miss of an atomic bomb-sized impact? And the answer was just over a week ago. Asteroid 2020 QG, and I'll explain what that designation means later in the semester, passed by Earth August 16th at a distance of only 1,800 miles from the surface of the Earth. So that's only about 3 times higher than the space station, or I guess more than that, but about 4 times higher than the space station. But this was a near miss right here. This is actually underneath a whole bunch of our satellites, and we didn't see it until right after it passed by. Because it was coming from the direction of the sun. So, what this means, of course, it means the sky really is falling. There are other things that also affect Earth called solar storms. Basically, what happens is the sun burps, and technical terms coronal mass ejection, sends a blast of material across the solar system, which can slam into Earth's magnetic field. When that happens, it creates what we call a geomagnetic storm. A geomagnetic storm can do several different things. It can trigger magnetic variations on Earth. It can trigger radiation exposure. It can electrical current, radio blackouts. For example, a number of years ago, there was a big geomagnetic storm that in the 1990s that caused radio blackouts that basically blocked out police radio across much of the western United States. There was another geomagnetic storm that affected navigation systems for ships at sea. You can also, there was one in the early part of the 21st century that knocked out the GPS system for an entire afternoon. It also knocked out any debit card, credit card transactions. You try to like pay for something with a debit card. If it was a satellite link, it wouldn't work because it couldn't talk to the satellite. Back around 2013, there was a big geomagnetic storm that created a radiation event so that if anybody was on a transatlantic aircraft, they'd receive up to 200 chest x-rays worth of radiation exposure during the flight. They didn't tell the passengers that they weren't going to take off because it was radioactive. They called it a weather delay. That's not technically incorrect because this is in fact called space weather. One of the biggest geomagnetic storms occurred again in September of 1859, so huge that it actually caused electrical discharges that knocked out the entire telegraph system across the United States. Now, normally that would be a big deal today, but today we have power lines running across the U.S. An event like this, it was called the Carrington event. You can look it up online. The Carrington event was so powerful that if it were to happen today, it'd knock out all of the electrical transmission lines. And I don't mean just knock them out temporarily, I mean permanently. That means all those high tension lines you see across the country would have to be replaced. All the substations, all the generating plants would have to be replaced because they'd all be blown out completely, irreparable. How long would it take to rebuild the entire infrastructure of the United States? Decades. We would basically be without electricity for decades. You can't say, well, I'd be okay because I got a generator, because your generator needs fuel, and there'd be no electricity to pump fuel or even to provide gas or anything. So that would be basically the end of civilization as we know it. Could that thing happen? And yeah, it can. 2012, there was a storm the same size as the Carrington event storm, but the coronal mass ejection was directed in a different direction across the solar system. It missed Earth altogether. So we'll talk more about solar storms and geomagnetic storms later in the semester. Okay, so other things that can happen besides the solar activity, solar variation, the sun can actually get brighter or cooler. That would affect Earth. Gamma ray bursts, a giant blast of radiation from space. There's even evidence that the orbit of a planet is not 100% stable. They can be shifted a little bit. That would totally disrupt the climate on the Earth. And of course, we already talked about impacts, things running into Earth. So there's actually a lot of things out there that affect it. And again, this is a graph right here of solar variation over over a couple hundred years, and you can see that it's not steady. The sun does very little bit, and that actually affects climate. Not just human activity, but also solar activity affects the climate. So why do we study astronomy? Historical reasons, culture, science, because it's just downright cool. Self-preservation, understanding what's happening up there affects us here on Earth. But the real reason most of y'all take science is because you need a laboratory science credit. Okay, and so astronomy is really cool science to take for that.